Okay, so section 7.6 is the rational zero theorem, or you might sometimes hear it called the rational root theorem, okay? And it looks a little confusing when you see it all written out. It says if the polynomial p of x has integer coefficients, then every rational root of the polynomial function can be written in the form p over q, where p is a factor of the constant term. So that's going to be the number on the end. And q is a factor of the leading coefficient. Okay, so I'm going to do a couple examples so you guys can see what this is. It's a little weird. Okay, so it says list all possible rational zeros of p of x equals 4x to the fourth minus 2x squared minus 7. So our possible rational zeros are in the form p over q, and p is going to be the factors of negative 7. The number on the end. We don't really worry about the sign, just 7. So factors of 7, things that go into 7, 1 and 7, right? And q is going to be the factors of the leading coefficient. That's the number in the front. Maybe I should have said number in front. So q is coming from there. So factors of 4, we would have 1, 2, and 4. Yep. And it's every combination of those numbers in plus and minus form. Okay, so my possible places that I can have x-intercepts, so like places where I'm crossing, there's only a certain number of possibilities, okay, if it's a rational number, a nice like fraction or whole number integer, one of those numbers. Okay, so here are my possibilities. I could have 1 over 1, which is 1. I could have 7 over 1, which is 7, right? I could have 1 over 2, right here. I could have 7 over 2. Or I could have 1 over 4 and 7 over 4. And all of these are plus or minus. So how many possibilities do I have? You have a lot. You have 12 possibilities because they're positive or negative. But think about the infinite number of numbers on this axis. There are an infinite number of possibilities, and we've eliminated it to 12. That's pretty darn good, right? So this first one is just saying list the possible rational zeros. It's not actually having you find the zeros. On these next ones, we're going to actually find the zeros. Okay, so we're going to go an extra step, and this is kind of how your homework will be. So this one says find all of the rational roots. So question, looking at x cubed plus 3x squared minus 4, do we know how to factor this? How do you factor it? It's x cubed, right? It's not x squared. So we don't know how to factor it. What this theorem allows you to do, and this is why it's my favorite theorem, is it allows us to factor things that look like that. Okay, so it doesn't look like it factors, right? It's like I can't do my 2 sets of parentheses. How do I do that? But it actually does factor. Okay, so here's what we're going to do. We're going to list the possibilities. So do you guys have that part down? So p is going to come from the factors of the last number, 4, 1, 2, 4. And then q is going to be the factors of the leading coefficient, which is 1. So it's just plus or minus 1. Q often is 1. I don't get very crazy with my q's. A lot of times I make them 1. All right, so that means I have possibilities of 1 over 1, 2 over 1, 4 over 1, right? So I'm going to have 1, 2, 4, negative 1, negative 2, negative 4. And in the last section, we talked about how to find a zero, right? We said if we can plug in something using synthetic division and we get a remainder of 0, then it factored evenly, right? So that's what we're doing. We're doing a continuation of that. Remember the remainder theorem? Okay, so we're going to try, let's say, 1. And we're going to try it with synthetic division.
Wait, how are we converting this into synthetic division?
So we're going to take this quotient, or this dividend, and we're going to divide it, and we're going to get a quotient out. So our dividend is going to be 1x cubed, 3x squared, 0x minus 4. So make sure you rewrite so you can see that 0x. So it was x cubed plus 3x squared plus 0x minus 4. That's where those numbers were coming from. 1, 3, 0, negative 4. And we're going to test these numbers. So we can test 1, 2, 4, negative 1, negative 2, or negative 4. Yes?
Sorry. Where does the 1 come in?
The 1, it's one of our possibilities. So we're just trying one of them, okay?
Oh, okay.
So let's say I try 1. So I drop my first term. Anytime I go diagonally, I multiply. 1 times 1 is 1. Add straight down, I get 4. 1 times 4 is 4. Add straight down, I get 4. 1 times 4 is 4. Add straight down, I get 0. All right, so what does that mean? It means it factored evenly, right? We got a remainder of 0. So how did it factor? Our original polynomial has now factored into the divisor times the quotient. So our divisor comes from the 1. So do you guys remember what I write in the little parentheses? X minus 1, right? And then the quotient comes from the 1, 4, 4. So what do you write in the bigger parentheses? X squared plus 4x plus 4. Do you guys all remember that? We did that in chapter 5. Okay. Now you could continue using synthetic division, and you could try 2 and 4 and negative 1 and negative 2 and negative 4. Or what can you do? You could factor. Does everybody else understand this? Nick understands it.
Wait,
Everybody else is good? Yeah.
how do we know which number to use?
You just try anything. So sometimes it works, sometimes it doesn't. Hi.
You got me, Brooke.
I do. She's right there.
That's probably what I'm taking on some time.
We're going to talk about ways that will make that easier, Christian. All right, so notice how this one factors further. So it factors further into x plus 2, right? So if I'm trying to find the zeros, the roots, x-intercepts 0, so those all mean the same thing. I get x equals 1, negative 2, and negative 2. If I was graphing it, this would be the places where it crosses, right? And negative 2 and 1. My end behavior would be like this. Do you guys know the y-intercept? Negative 4, yep. So I have multiplicity of 2 at negative 2, so it bounces, goes through the y-intercept, and then goes up there. That would be how I would do a rough sketch. Okay, it's all interconnected. Okay, you don't have to do a rough sketch. I was just doing that so you guys can see it. All right, so that's why we bounced there, because we had multiplicity 2. Oops, so right there it bounced. All right, do you guys understand that? So the question is, do we have to do synthetic division for lots and lots of numbers? Sometimes. Okay, so when I was in Algebra 2, we weren't allowed to use calculators. Yes, calculators, graphing calculators were around. People have asked me that. I'm not that old. We've had graphing calculators when I was in high school, just everybody couldn't afford them. So we didn't use them very often. And so I remember it was frustrating sometimes, because sometimes there are a lot of possibilities, okay? But a lot of times, once you get one that works, you're good, because then you can continue to factor, or you could use quadratic formula. So as long as you're getting one that works, you're good. So let's try number 3. So it says find all rational roots of this function. So if I'm finding my possibilities, I'm doing my P over Q. I'm taking my factors of negative 2, so 1 and 2, and my factors of 6 are 1, 2, 3, and 6. So you could write those out. You have 1 over 1, 1 over 2, 1 over 3, 1 over 6, 2 over 1, 2 over 2, 2 over 3, 2 over 6. Some of those are repeated. You see how 1 over 3 is the same as 2 over 6. Okay, so you could do that. If you're trying to really quickly test one, a good one to test in your head is 1. Because if you can plug in 1 into the function and get 0 out, that also means it's an x-intercept. So can you guys easily do that in your head? Some of you guys can. Like some of you guys are going to be like, oh, I have 6 minus 17 plus 11 minus 2. Would that work? No, it doesn't make 0, because you get negative 11 plus 11 is 0, and then minus 2, it's negative 2. It doesn't work. Okay, so sometimes you can kind of eliminate choices by plugging them in, but most of the time synthetic division is much, much faster. So don't just like say, oh, I don't want to do all these synthetic division ones. Sometimes you got to do it. So let's say we tried 2. So I have 6, negative 17, 11, and negative 2. And my goal is I want to get 0 at the end as my remainder. So let's see. 2 times 6 is 12. Add straight down, I get negative 5. 2 times negative 5 is negative 10. Add straight down, I get 1. 2 times 1 is 2. Add straight down, I get 0. We were lucky, weren't we? It worked. Yeah?
Why does like 2 over 2 not simplify to 1?
It would. Like you could write these out and you could say, okay, I have 1, I have 1/2, I have 1/3, I have 1/6, and then do the 2s. So you can say 2 over 1 is 2, but then 2 over 2 is again 1.
Oh, okay.
2 over 3 works. Yeah. And then 2 over 6 is again 1/3. So really there's going to be 1, 2, 3, 4, 5, 6. There's 12 possibilities minus the plus or minus. All right, so we did get one that has a remainder of 0, so that's good. That's what we wanted, because now it allows us to factor. So we factor our f of x into its divisor, which was x minus 2, times the quotient, which is 6x squared minus 5x plus 1. So from there, we have an x squared equation, a quadratic equation, right? Which we can then use the quadratic formula on, or we can factor. This one, I believe, factors. So we factor again. So we have 3x and 2x, 1 and 1, and they're both negative. You see it? How the outer and inner combine to be negative 5x, and our last term's made positive 1. So we're good. And we just drop that x minus 2 again. And our goal is to find the roots, which are zeros, x-intercepts. So I plug in 0 for y. So I get 3 solutions. Do you guys remember why there have to be 3 solutions? Because the degree is 3, exactly. It's all going together, right? So if I add the 1 over and divide by 3, I get x equals 1/3 and x equals 1/2. Those are our 3 solutions. A lot of times people will forget the 2 because they just factor this one and then leave out the x minus 2. So always write its factored form so you can see that one as well. Okay, so those are our solutions. Is this making sense? If it didn't factor, then we would do quadratic formula. Maybe we have I answers or square root answers, right? We could have that as well. All right, so number 4. So I was telling you when I was in high school, we did not have graphing calculators. You guys all have graphing calculators in this class. So you can cheat your way through life. Not really. On the test, remember, you're going to have a calculator section and a non-calculator section. But if I have one like the following, and you do your P over Q, and you're like, 36? Why would Mrs. Cox do this? 36? Let's think about the factors of 36. 1, 2, 3, 4, 6, 9. Have you guys seen the rainbow method? It's like where once you get to the middle, you're like, okay, now 4 and 9, 3 and something, 2 and something, 1 and something, right? So we have 1 and, okay, yeah, it's a rainbow. That's why I called it the rainbow method. 12, 18, and 36. So you can get all of those factors, right? Let me not get rid of my blue here. I'm going to write them again. So we have 12, 18, and 36. That's a lot of factors. Can you imagine if Q was just as big? Oh my gosh, it would be terrible. But Q, we luckily just have 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2, because plus or minus 18 possible places where it can cross the x-axis. That's when I am like, nope, I'm going to graph this and see where it looks like it's going to be. Okay, so go ahead and try that. Graph on your graphing calculator. And I tried to put it off to the side if you guys didn't have a graphing calculator. So if I go to my y equals, and I put in x raised to the 5th plus 3x to the 4th minus 9x to the 3rd minus 31x squared plus 36. Oops, 36. And I hit graph. It gives me a little graph here. Mine's thinking. And I can kind of count. I can say, ooh, this one looks like it's close to 1. This one is probably 2, so 3. So 1 and 3, maybe at -2, -3. Do you guys see those where it looks like it's crossing the x-axis? It's like here, 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 and here. You see it? So on the picture, you can kind of see it as well that I have graphed for you. Do you guys know you have something on your computer called Grapher where you can also graph? This is what I graphed it on Grapher. So I have, this was -2. This looked like -3 probably, based on these little tick marks. This is probably 1, right? So I would probably, with synthetic division, try the things that look like they're zeros, right? So let's try 1 first. Now be careful because this one is missing a term. And with synthetic division, you always want to put in zeros if it's missing. Do you guys see what it's missing? Yeah, it's missing that 0x in there. So be careful when you write this down. So I have 1, 3, -9, -31, 0, and 36. And I do my synthetic division. So 1 times 1 is 1. Add straight down, it's 4. So continue doing that. So I'm not going to write it directly below because I'm going to actually continue my synthetic division using my result from this last one. But we're going to write off to the side what this factored form is. So off on the right-hand side, let's write, we had our x minus 1. And then if I started with x the fifth, what do I have now? X the fourth, right? So I'm going to have x the fourth plus 4x cubed minus 5x squared minus 36x minus 36. Okay, and this next polynomial, it doesn't look like it factors either, right? It's like, well, how do I factor this? You could maybe split the middle, but you can't, right? It doesn't split the middle. So we continue with what we're doing. We continue to factor it with synthetic division. So what would be another good number to try? -2, right? Looking at your graph, -2 looks like a good one. So now I just continue my synthetic division. I'm lazy. I don't want to rewrite it. I continue it here. And we just kind of cross out that remainder of 0. So I drop the 1. -2 times 1 is -2. Add straight down. Right, continue. Are you guys all good at synthetic division? I don't have to say every step, do I? So we get that. So now this other polynomial has now factored. It factored into x plus 2 because we had -2 working. And now it's x cubed, right? So x cubed plus 2x squared minus 9x minus 18. And then that x minus 1 just drops down, right? So we're like that. So we could keep going. You could keep trying other things. You could keep breaking it down. That's the goal. We want to try to break down our polynomial. But now, do you guys see that this one factors by grouping? We could do it that way, right? Split the middle. We pull out the x squared. We have x plus 2. What do we pull out in order to get -9? Jacob Mason Cup is just like saying everything else over that back there. You got it. So then x squared minus 9, he's like, oh, x squared minus 9 is, I heard him say it. So you have x plus 3 times x minus 3, and we still drop these ones. So we have x minus 1 and x plus 2, and you guys just learned how to factor this polynomial. Isn't that so exciting? It's the most exciting thing ever. You just factored it. Look how it factors. So if I multiplied that all out, I would go back to that original polynomial. Isn't that crazy? No, no one else thinks it's cool. This is like the coolest theorem ever. No one else.
No, I'm just trying to understand it. I'm still.
So we've taken that original function, this original polynomial, and we have factored it into this.
I understand that.
So its solutions, we have 5 of them. We have 1, -2, which actually has multiplicity 2. It's listed twice. We have -3 and 3. Why do we have 5 answers? Because it's an x to the 5th equation. We should have 5 answers in the end. That's what we did. These are all the x-intercepts. Now look at your graph. If you looked at it on your graphing calculator, you would have seen that it goes back up, right? Well, this part is going back down. It should at some point go back up. That's this line over here. So really my window isn't the best for this. I could adjust my window. That didn't really help too much, did it? Like if I wanted to figure out where it went back up, you can sometimes do zoom fit. So if you hit zoom and then you go down to zoom fit, but sometimes it doesn't work. It works in stats classes, but it doesn't always work in Algebra 2 and pre-calc. Sometimes it doesn't give you a good one. So it's showing it going up. And then see, it's not showing too much going on there. It's like, wait, what just happened in the middle? It's like zoomed in too much there, or too zoomed out, I guess. So if we go to window and see if those are like crazy big. Let's make this like -100 to 100. Do you guys see what I did? I hit window, and then I changed the Ymin, Ymax, and now I hit graph.
I can get it so that it'll tell you the numbers that are on the x-axis, because I keep getting it so it says each x unit that you press the button will be some weird number, and I can't quite get it to work correctly. Also, how'd you get it?
I don't know. I'll look at yours after class. It sounds like there's some kind of weird setting on yours. All right, so you can do that. So I basically made my window -10 to 10, or I could make that even closer. I could do -5 to 5 for my x values, and my y's from -100 to 100. So it's kind of zooming in a little bit more there, so we can see that there's stuff going on. But if you were curious as to what was happening here, then you could change your window just to this area. You can even do something called zoom box. If you were like, oh, what is happening over in that area? There's lots of different things you can do with Zoom, and we'll be doing this throughout the year. More in pre-calc, we do a lot of graphing calculator stuff. But you could hit Zoom box and you could zoom in on that area if you're like, ooh, does that have multiplicity? What's happening there? And then you can look at that, and that's showing you this portion of the curve. You guys see on my sketch. It's showing you this part, and it does show you that it bounces on -2, which means it has multiplicity. So there's lots of things you can do to see what's happening on that graph. All right, so anyway, so those are our 5 solutions. So let's go here. So it says find all rational zeros of the function. So if I'm finding the zeros, I'm still doing my P over Q thing. So go ahead and try it along with me. So be active note takers. Try to do the problem along with me. So my factors of 8 are 1, 2, 4, and 8. And my factors of 1 are just plus or minus 1. And you can try different things. If I plug in 1, am I going to get 0 out? 1 plus 10 plus 33 plus 38 plus 8. No, because I'm getting bigger and bigger and bigger, right? Do you guys see if I plug in 2? What happens if I plug in 2? It gets really, really big, right? These are all positive numbers. They have pluses in front of all of them. So if I'm plugging in 2, 4, or 8, or 1, this is going to be a huge number. It's not going to be close to 0. So our answers are probably negative, right? So this is where Descartes' rule of signs comes in. You can eliminate a lot of possibilities. Like, let's say you do Descartes' rule of signs and you're like, oh, I don't have any sign changes. Well, if you don't have any sign changes for f of x, then that means that you don't have any positive real solutions, right? So we don't try any positive numbers. We would only try negative numbers, right? And let's say we do Descartes' rule of signs and we only get 1 for our negative answer. And then we do synthetic division and we got like -2 worked. Well, then that's the only one that's going to be negative. Don't try any more negatives. Okay, so that's how that can be useful. We don't use Descartes' rule of signs a lot, but it can be useful. All right, so let's say we try -1. Did anybody try that? So we have 1, 10, 33, 38, and 8. I'm not sure if this one works. -14, yeah, it doesn't work. So if it doesn't work, this is the first one we had that doesn't work. Just cross it out. It's okay, not a big deal. Sometimes factoring doesn't work, right? We tried to factor, it didn't work. So let's try -2. So 1, 10, 33, 38, and 8. A lot of times I am nice and I make 1 work because that's usually the first thing people try. So on the test, I do have 1 working a lot. What do we get here? 19, -38, 0, -0. Oh, that didn't work either. All right. Anybody get anything work? Yeah. Did I do a mistake?
Yeah, did you multiply -2 times 1 to get -3?
Oh, yeah, what did I do there? I don't know. Why did you tell me before I got to that, guys?
Sorry.
You're like, Mrs. Cox, you're crazy. All right, yeah, 8. I kept thinking, like, I could have swore this worked in the other class. Why is it not working now? Now I see why. All right, thank you. Bonus point for Olivia, right? See, Brooke, they get bonus points when they correct their teacher. Isn't that nice? Did you say I need to be a time traveler to go back and get those more bonus points? All right, so factor it. So I have x plus 2 times x cubed plus 8x squared plus 17x plus 4. So that's how it factored. So now that we have something that's x cubed, we can always look to see if we can split the middle. But this one actually doesn't. Do you guys see why this one doesn't split the middle? Yeah, 17 is prime. So like, if you pulled out an x squared from the first two, you'd have x squared and then in parentheses x plus 8. Is there any way that you can get x plus 8 over here? No. Yeah, so she's saying 17 is prime. There's not any way that you can like pull that out and like get what we want. So we can't split the middle. So we now continue synthetic division. We go again. So what do you want to try? Anybody get one that works? Negative what? -4. So we drop the 1, -4, 4, -16, 1, -4. Because we're now trying to factor this one. You never want to go back up to the original. This is a good point to make. Don't go back to the original because our whole goal is to slowly factor down, right? We want to break it apart, break it apart, break it apart. So don't go back to the original. Like continue factoring what you have now. So we're now factoring this one right here. We're breaking it further apart. All right, so now we have our x plus 2 from before, and this one broke into x plus 4 times x squared plus 4x plus 1. That's what the 141 over there was. Now we try to factor. Joey's wrinkling his eyebrows like, It does not factor, does it? Darn. Quadratic formula, we do. Quadratic formula. But actually, this one does just say find the rational roots. But we would do quadratic formula to find square root and I answers. I won't put you through that. So our rational answers, the only two rational answers are -2 and -4. Done. You guys understand what I'm saying? So if it had a square root answer, it's called an irrational number, irrational solution. And if it had an I answer, it's a complex solution. So on the next one, though, it says find all solutions, real and complex. So every type of solution. So this one you probably will have to break up further. You guys getting some good practice in? You feeling good about this? All right, so let's get everything on one side. So I'm going to start with my x to the 4th. I'm going to subtract my 7x cubed over, so I'm going to have minus 7x cubed. I'm going to have plus 27x squared minus my 47x plus 26. So I got everything on the right-hand side. Yep.
Never mind, sorry.
Okay. She's going for a double point, huh?
No, I was actually.
You got it. All right, so we need to try something. How about this side of the room, you guys try 1. So when we do our P over Q, what do we have? 1, 2, 13, and 26. I'm going to guess it's not 13 and 26. Let's hope not. So I would say 1 and 2, or -1 and -2. So how about this side of the room, you guys try 1. This side of the room, you guys try either 2 or -1.
How'd you get the
Jacob, you get one that works? Yeah, Nick? Which one? 1, he says 1 works. All right, let's try it. So if I have 1, 1 times 1 is 1. Add straight down, I get -6. 1 times -6 is -6. 21, 21. It does work. He's right. -1 works as well. Well, that is going to be very handy for us, right? Because now we've factored into x minus 1, x cubed minus 6x squared plus 21x minus 26. And this is another x cubed one that doesn't factor by grouping. Because we pull out an x squared and have x squared and x minus 6. But there's no way to get x minus 6 over on the right side. So Abby's saying -1 might work as well. Does it work? Oh, she did it in her head. I trust your head. I think she's a smart cookie back there. She's probably got it. Let's hope. Oh, man, off. Maybe I was off. All right, so -1 doesn't work. What else? 2, did it work? You don't know? We're just guessing? Let's try it. And it really doesn't take long to actually try it, right? It's not like a huge deal if... Oh, it works. So now it breaks into x minus 1, x minus 2, x squared minus 4x plus 13. And x squared minus 4x plus 13, sad day, does not factor. So we do the quadratic formula. So our quadratic formula, we would do x equals -b, so -4 is 4, plus or minus the square root of b squared, so -4 squared is 16, minus 4ac all over 2a. So we get 4 plus or minus 16 minus 52. What do we get there? -36? Yep, so it is 6i. So we're going to have 4 plus or minus 6i divided by 2. Just in time for Valentine's Day, our little heart, meaning that the 2 goes into both 4 and 6. So we're going to have 2 plus or minus 3i. So those are 2 of our solutions. and we also have 1, and we also have 2. Do we have the total number of solutions? Yep, because our degree was 4. Is this making sense? Do you guys understand? All right, so they're not always like these ones. So sometimes you do have story problems. So the next one is a story problem. I think I'll probably show you this during your double, though. So we might just pause here. Should I go back there? All right, let me stop this. And I'm going to show you how to cut out a piece of paper to talk about the next. Yesterday we left off and we were doing craft time with Mrs. Cox. Do you guys remember when I cut out the little squares in the corners? And so now you understand that it needs to be squares and not rectangles that you're cutting out. So these types of questions are on every single math book from here on out. They're in every Algebra 2 book, every pre-calc book, every calculus book. They are always talking about an open top square box, or open top box. So we're making it out of a square piece of material that was originally 10 inches by 10 inches. And we're cutting equal squares from the corners and turning up the sides. Okay, so we're cutting out this little x by x square. So when we do that, we have this distance that's left right in here. Okay, and Claire said this yesterday. She was like, oh, it's, you have the original 10, and we subtract out the x and x, so we're going to have 10 minus 2x. So that's going to be 10 minus 2x there. And we're also going to have 10 minus 2x here. That's a minus. So when we talk about the volume of the box, these pieces, the length and the width, are going to be the same thing, the 10 minus 2x. Does everybody kind of visualize what's happening there? Do you guys get it? Okay. So when we talk about the volume of a box, it's always the length times width times the height. So our volume is going to be the length, 10 minus 2x, times the width, 10 minus 2x, times the height, which was x. And it says that we want to make an open box from a square piece of material, 10 inches on each side, by cutting equal squares. What size of square would you cut from each corner if the volume must be 48 cubic inches? So we want all of this to multiply out to b. Instead of v, we're going to write 48 for v. Okay, so there are ways to use a graphing calculator to solve this. We're going to talk about how to solve it using our rational roots theorem, right? The p over q. So we're going to FOIL it out first. So I'm going to have 100 minus 20x minus another 20x plus 4x squared. And I'm going to multiply by x. So when I do that, I'm going to have 4x cubed minus 20x squared minus another 20x squared, so minus 40x squared, and then plus 100x, and that's all equal to 48, right? So we're going to subtract that 48 over. So that's our function. So 4x cubed minus 40x squared plus 100x minus 48. Do you guys all see that? And we could start with our p over q right now, but the factors of 48, oh my gosh, the factors of 48, yikes. 1, 2, 3, 4, 6, 8. There's a whole bunch of them, yeah. So next thing, we have a GCF, right? Let's pull out the GCF. Do you guys see we have a 4, a 4, a 4. The 4 is in common to all of them. So we're going to pull the 4 out. And when we do, we have x cubed minus 10x squared plus 25x minus 12. That is much easier. Because now when I think about my p over q, I'm taking p to be negative 12 and q is going to be 1. So I'm going to have plus or minus 1, 2, 3, 4, 6, and 12, and plus or minus 1. Still a lot of possibilities though. So let's think about this logically. We talked about this yesterday. If you have a big box that's 10 by 10, and you're going to cut a square out, what size of square would be too big? What size of square is going to make it run into each other? 5, right? 5 inches on each side, that's too big. Anything bigger than 5 means you're cutting out, like if you cut out 6 inches from the right and 6 inches from the left, wait a second. There's not enough material to do that, right? So 6 and 12 are automatically out. And the negative answers are also out, right? So we only have possibilities of 1, 2, 3, or 4. All right, so I would use those with your synthetic division, 1, 2, 3, or 4. I tend to pick things like 2 or 3 because I think like 1 and 4 create kind of a weird box, right? Maybe it's a really skinny box. I don't know what you would put in this box. Or a really, really flat box. Maybe like a tie. I don't know what you put in a really flat box like that. Do you guys get it? So you might have boxes that look like that, but I would tend to try like the 2 or the 3 first. So let's try I think 3. So I'm going to have 1x cubed negative 10x squared 25x minus 12. And I do my synthetic division. So 3 times 1 is 3. I get negative 7, negative 21, 4. Oh, it was a lucky guess. I couldn't remember if it was 2 or 3. I just guessed 3. Shoo. Don't you hate it when you have to try multiple things? Did that happen to you on your homework where you had to try more than one thing? And you're like, Mrs. Cox, why? So mean. At least you have calculators. You can always graph it and see. All right, so we've factored into, we still have the 4 out front, then we have x minus 3, and then x squared minus 7x plus 4. And the x squared minus 7x plus 4 doesn't factor, but it doesn't mean that it couldn't be a solution. So it might have an I solution, it might not. You could test the discriminant. Do you guys remember what a discriminant is? B squared minus 4. See the part under the square root, right? You could test that to see if it's going to be an I answer. B squared is 49 minus 4 times 1 times 4. Oh, it's going to be positive under that square root. So we got to do this. So we'll really quickly do this. So we're going to have x equals negative b, so negative 7 is 7, plus or minus the square root of b squared minus 4ac all over 2a. And it's not pretty, but we'll find the decimal version. So we have 49 minus 16, 33 over 2. So if I was putting this into my calculator, I would do like just the numerator first and hit enter. So go ahead and do this along with me. Make sure you guys get the same answer. Oops, so loud. All right, so I'm going to do 7 plus the square root of 33, and I'm going to hit enter. And then I'm going to take that answer and divide by 2. So when I do the first answer, so using the plus, was 6.372. Do we think that can work? Can you cut out 6.372 inches on each side? No. That's out. Too big. All right, but that doesn't mean the other one doesn't work. So 7 minus the square root of 33. Hit enter. Divided by 2. What do we get? 0.6277 something says 0.628. That one is still a possibility. What does the box look like in that case? Like a really short box, but really wide. That's like one for a tie. I don't know what would go in that box. It's still like a square shape though. So I don't know what would go. Like a painting, yeah, like on canvas. You could put a painting in there. There's no like, wouldn't be able to frame it. Just like something really thin. So it could be that, or it could be x equals 3. Probably 3, right? But that one actually has 2 solutions. Does this make sense? All right, and the last thing we have to talk about is the irrational root theorem. So it just says if we have a 0 that is in the form a plus the square root of b, then you also have a solution that's in the form a minus the square root of b. And that comes from the quadratic formula. Okay, so it says identify all of the real roots to 2x cubed minus 9x squared plus 2 equals 0. So my possibilities when I do my p over q are plus or minus 1 and 2, and plus or minus 1 and 2. So I'd have 1, 1/2, 2, and then 1 again, right? So 1, 1/2, 2, and then negative 1, negative 1/2, negative 2. There's 6 possibilities. All right, anything that you guys want to try? I think 1 does not work. Can you guys check that in your head? 2 minus 9 plus 2, is that going to be 0? No. So maybe we tried 2. Let's try 2. So be careful, this one is missing an x term. So we're going to put in 2, negative 9, 0, and 2. Then we do our synthetic division. Oh, it's not looking good. 2 didn't work. Negative 2 maybe? Actually, I think it's like 1/2. Let's do 1/2. Yeah.
If we're ever like on the test and we realize something isn't working, can we just like stop?
Yeah, you can just stop and cross it out, yeah. So let's try 1/2. So 2, negative 9, 0, and 2. Maybe. Yep, this one works. All right, so 1/2 worked. So that means we've factored into x minus 1/2, and then we have something with x squared. So 2x squared minus 8x minus 4. So we do have a GCF of 2, and that will always happen if like 1/2 is a solution. Like, see how we can pull out a 2? So it's really like, if you didn't like that x minus 1/2, you could put that 2 in with it. So it'd be 2x minus 1, right? So you could always do that. So 2x minus 1, not that that matters. And then we have x squared minus 4x minus 2. So sadly, x squared minus 4x minus 2 doesn't factor. So this is where you would do the quadratic formula. So you'd say, I know this solution gives me x equals 1/2, but this solution comes from the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So 4 plus or minus the square root of 16 minus 4 times 1 times negative 2 all over 2. So it's the square root of 24 that's in there. So 4 plus or minus the square root of 24 all over 2, which is 4 plus or minus 2 root 6 over 2. Just in time for Valentine's Day. Our little heart. Remember our heart? So 4 plus 2 root 6 all over 2 is going to be 4 over 2 plus 2 root 6 over 2. So what do we get? Yeah, 2 plus or minus root 6. Do you guys see why, if you have an irrational answer, so if I had 2 plus the root 6, I also have to have 2 minus the root 6. Okay, it comes from the quadratic formula. Same with the i's, right? If you have an I solution, you have to have its conjugate as well. So our three solutions are 1/2, 2 plus root 6, 2 minus root 6. Does this make sense? All right, and then likewise, we can have polynomials with these. This one's kind of a complicated polynomial. I'll start this one out. Maybe we won't finish it. We'll see how we're feeling. So this one, if I have 2i and I have 2 plus root 3, what else do I have to have a 0 if I have 2i? Negative 2i as well. What about this one? 2 minus root 3 as well. So when I set up this polynomial, some of you guys were having trouble on your homework with this, it's going to be x minus every single 0. So x minus the 2i, but also x minus the negative 2i. So it becomes plus 2i. And then x minus parentheses 2 plus root 3, and x minus parentheses 2 minus root 3. So if I distribute that negative, it's going to be x minus 2 minus root 3 times x minus 2 plus root 3, like that. Some of you guys will know what this is, foiling it out already, because you know that something that's the sum of two squares will have answers of 2i and negative 2i. What is the sum of two squares that I'm looking for? Anybody know it? Greta? X squared plus 4, not 4i though, 4. Do you remember x squared plus 4 will have answers of 2i and negative 2i? If you weren't sure, you FOIL it out. You get x squared plus 2ix minus 2ix, so it goes away, minus 4i squared. So that becomes x squared plus 4. I squared is negative 1. And then we would multiply this part out. Right? I'll just do it for you guys. You don't have to do it all. Do you guys remember you can take the x, you would take the x into all three things, you could take the negative 2 into all three things, or you take, and then you'd take the negative root 3 into all three things. And then you would simplify, simplify, simplify. I'd also taught you the shortcut. You can have x minus 2 squared minus root 3 times root 3 is not, root 9, which is 3. Almost got a bonus point. I saw you looking, Nick. You were like, yes. So we have x squared plus 4 multiplied by x squared minus 4x plus 4, and then minus 1, or minus 3. So x squared plus 4x, no, x squared minus 4x plus 4 minus 3 is going to be plus 1, and then you multiply this out again. So this is a long one. This would be like something that I would put as a bonus on your test. I wouldn't make you do this on the test because it takes a long time. I never want you guys to be panicking like you're going to run out of time. All right, x to the fourth minus 4x cubed plus x squared plus 4x squared minus 16x, just write the answer, plus 4. So your final answer should be, did anybody find it? No, you're just like, do it for us, Mrs. Cox. All right, minus 4x cubed plus 5x squared minus 16x plus 4. That's our polynomial. So one thing that does drive me crazy is when on your homework you guys just write the answer, because I'm like, there's no way that you just got the answer. So show your steps, right? You have to show your steps on things like this. So I'm not going to give you credit if you don't multiply it all out. It's magic. All right. So that is the end of 7.6. Let me stop.